In this lecture, we will be talking about the encoding of characters. You must keep in your mind that the characters entered from the keyboard are not directly stored in the computer memory. It is because the memory stores a character in numeric form, that is, their binary form. Hence, the characters entered from the keyboard are encoded into numeric form before actually getting into the memory of the computer. Basically, two types of encoding schemes are used in computers to encode the characters. We will talk about these two types in the following slides. The first type is ASCII code. ASCII stands for American Standard Code for Information Interchange. It uses 7 bits of code for representing each character. It includes 256 characters, but only 128 characters are used while designing and executing a program. ASCII code represents these characters as numbers, with each letter assigned a number from 0 to 127. You must remember that the 128 characters which are used are numbered as 0 to 127 and not 1 to 128. So I have made a table of the most common codes and their respective characters. The codes are 48 to 57, whereas the characters are 0 to 9. This may seem a little bit confusing, but actually, the number 0 stands for 48 in ASCII codes. And similarly, the numbers after 0 follow the same order, such as 0 stands for 48, 1 stands for 49, 2 for 50, 3 for 51, and so on. So as you can see, 9 stands for 57. Now let us see what characters come next. The next characters are capital A to capital Z. The capital letter A is represented by the number 65 in the ASCII code, whereas capital Z is represented by 90. Similar to this number system, the letters follow this sequence. A is 65, B is represented by 66, C 67, Z 90, Y 89, X 88, and so on. Now let us look at the lowercase letters. At first, when I also saw the ASCII codes for the smaller lowercase letters and the uppercase letters, I was shocked because the lowercase letters ASCII codes were greater than the capital letters. As you can see, there is a difference of about 32 characters between these two, capital A and small a. And there is also a difference between Z and small z of about 32 characters. The most interesting one is that if we write 32 in ASCII codes, then it means that it will be a blank. Suppose that if I write 32 in ASCII code, then and if I print this, then it will not give me any output. Actually, it will give me an output, but we would not be able to see it because it is a blank. So now let's hop on to the next slide, which is talking about Unicode. Unicode is a wide representation of characters in numeric form. The code contains hexadecimal digits. First, let's talk about hexadecimal. In lower classes, you must have learned about binary and hexadecimal numbers. As you can see in the word itself, binary means 2. So it is represented by ones and zeros. So such example 100, 1010 or 0001. And hexadecimal, as you can see, hexa means 6. So hexadecimal contains 6 characters, which could be numbers or alphabets. For example, A, B, C, D, 0, F, or we could just write A, B, C, D, E, F. Let's move on to the range of Unicode. Unicode ranges from 0x0000 up to 0x followed by 4fs. It can accommodate about 16 bits of code. It can address about 1,37,000 characters from 146 modern and historic scripts. Oh, I'm missing a zero here. 1,37,000. Can you imagine? As compared to the ASCII code, ASCII code had only 256, out of which we could only use 128. And the Unicode contains 1,37,000 characters. The Unicode has about 1,000 times more characters than the ASCII. It means a code of each character is available under Unicode character set. It is a standard encoding system used to encode a character in any computer language. So these were the two types of encoding which we use in computer programming. Mostly we will be using ASCII codes in this course. If you want to learn more about Unicode, I will be attaching a link in the next lecture. So this was all for this video. I hope you enjoyed learning about ASCII codes and the vast world of Unicode. Thank you and meet you in the next video.